Process characteristics. The obtainable cutting rates in plasma arc machining are 250 to 1700 millimeter per minute, depending on the thickness and material of the workpiece. For example, a 25 thick aluminium plate can be cut at a speed of 750 millimeter per minute. A 6 carbon steel sheet can be cut at 4000 millimeter per minute. The use of water injection can increase the cutting rate in carbon steel to 6000 millimeter per minute for a 5 thick plate. Accuracy on the width of slots and diameter of holes is ordinarily from plus or minus 0.8 on 6 to 30 thick plates and plus or minus 3.0 on 100 to 150 thick plates. The depth of heat affected zone depends on the work material, its thickness, and cutting speed. On a workpiece of 25 thickness, the heat affected zone is about 4 and it is less at high cutting speeds. Safety precautions. It is utmost importance that the units are operated after ensuring that all health safety measures are observed. The plasma flame emits a highly intense beam, particularly strong in ultraviolet and infrared radiations. These radiations, if taken in large doses, might cause permanent damage to the eye in the form of cataract. Overexposure results in the gritty feeling in the eyes due to loss of sleep. Overexposures to UV rays may also cause painful skin burns, and in extreme cases, this leads to cancer. Though these radiations are very intense in all the plasma flames, the laminar plasma flame is much more dangerous. Hence, it is very important that proper glasses and proper dresses are worn before going close to the torch. The glasses should be good at ultraviolet and infrared cutoff, and most of the body should be covered. Applications. Profile cutting of metals, particularly stainless steel and aluminium, has been the most prominent commercial applications of plasma machining. Other metals like mild steel alloy steels, titanium, etc., are also profile cut rapidly and cleanly. Clearly, plasma machining has been considered for late turning, milling, and planing. Plasma arc machining is also used successfully in conventional turning and milling machines to machine very hard materials. Since plasma arc machining is offered with numerical control table and often with multiple torches capability to increase productivity. Advantages. The principal advantage of plasma arc machining is that it is almost equally effective of any metal regardless of its hardness or refractory nature. As there is no contact between the tool and the workpiece, only a simply supported workpiece structure is adequate. The cutting rate in this process is high enough to facilitate this method to be used on almost on all materials. Limitations. The main disadvantage of this process are the metallurgical alteration of the surface. Thus, a secondary machining needs to be performed to remove the surface by 1.5 or more unless it can withstand the hardened and uneven surface. Eye shielding and noise protection are necessary for the operation and those in nearby areas. Inert gas consumption is high. More chances of electrical hazards are associated with this process. The process is limited to metal thickness of 25 and lower for brittle welds or for butt welds. Advantages continued: excellent weld quality, uniform penetration, stability of arc, simplified fixtures, base metal to be melted, carbon and alloy steels, stainless steel, copper alloys, nickel and cobalt base alloys.